There are 3 types of rocks. We are going to learn these types of rocks over the next 3 or so classes, okay? There's igneous rocks, sedimentary rocks, and metamorphic rocks. The rocks all work together as far as interacting. Any rock can turn into another kind of rock. And here's how that happens. Ready, set, boom!
The rock cycle.
The rock cycle! Okay, now, the rock cycle, I think this looks incredibly complex.
Yes.
Okay, so I'm not asking you to draw this, but I do want you to get out on like a blank sheet of paper. We're going to start. Now, instead of like, oh my gosh, this is so confusing, I tried to color code it. So I'm going to highlight what my color coding is to try to help you make sense of this. Okay, these here are the igneous rock processes. These are the sedimentary rock processes, and these are the metamorphic rock processes. So don't get all freaked out by this yet. So we're going to learn this a little bit at a time. Alright? This, we'll get there. You'll get this by the end of the unit. But for right now, this is all you have to worry about. Today, this is what we're talking about right here. So I want you to draw this in your notes, okay? A nice circle, a nice square, and then an arrow going back and forth between them. Okay? So Brianna, make sure you get that in your notes. Then take out some paper and write it down.
Yes.
Okay, we'll write it down now.
I draw it going the opposite way. Like with the square on the right side of the circle.
I would prefer you didn't because this builds, and as it builds, it's going to be important where stuff is.
Alright.
Okay?
Oh, wait a minute.
How are you supposed to do this?
How are you supposed to do this? You draw a circle, and then you draw a square. And then I want you to draw an arrow from the circle to the square, and an arrow from the square to the circle.
Why are they circles and squares?
Doesn't matter how big.
We'll get there.
There's like so many of these.
Which is why, Melanie, this is why I'm breaking it down really small. One step at a time. Don't worry about the big picture. Worry about the small picture, and as you learn all the small pictures, then you can put it together. Okay. We are talking about igneous rocks.
So, is that where it goes?
Igneous rocks. Okay. Melanie wanted to know, shh, please don't talk. Melanie wanted to know what the circles meant. The circles are the different rock types. So you'll have igneous rocks, sedimentary rocks, metamorphic rocks, but we're just talking about igneous rocks today. So igneous rocks, that's what goes in the circle. Based on your assignment from last class, you should know that a rock is a solid chunk of minerals. Okay, so it is a solid chunk. This is a rock. Okay? Now, how do we get igneous rocks? Well, there's only one way to get igneous rocks. Igneous rocks must start as a liquid. Okay? That liquid, what do we call liquid rock?
Lava.
Lava and magma.
Oh.
Okay, so I'm going to write it like this. Magma and lava. Magma and lava. What's the difference between magma and lava?
Temperature.
Not necessarily the temperature, not necessarily the color,
The texture.
not the texture, it's liquid.
How dense? Like how? Like.
It's not how dense, it's where it comes from.
Uh,
Where do we find lava?
Volcanoes.
Volcanoes. Where are volcanoes? They're on the surface. So,
Magma's under.
and magma's underneath. So lava is on top of the earth, and magma is underneath the earth, or underneath the crust of the
Right
surface.
there.
is,
Happy?
Can't you put it like lava and then magma?
Yeah, so
why
like
not?
lava's on top and then magma's on bottom.
That makes sense.
You know what, if you want me to do that, I will do that. I have no problem with it.
It's much easier.
I think it symbolizes something.
I mean,
Then like divide it with lava.
Yeah, but like divided.
There, is that better?
is there really a difference between lava and magma? Between
The difference in lava and magma, the only difference is location. Okay? And we make that differentiation because what happens to this is it turns to an igneous will make the rock look differently if it's a magma versus if it's a lava.
That right in a rectangle?
The rectangle is the intermediate step. The igneous is the rock. In order to become an igneous rock, it must turn into a magma or a lava first. So wait a second, well how do we get something turned into a magma or a lava?
Water.
Heat. Lots of heat. If you want to melt butter on the stove and solid chunk of butter, what do you have to do?
You heat that.
You leave it out.
Turn up the temperature on the stove. Sit it down on the stove and it will melt. You add heat to the rock. So if you add enough heat to a rock, what will it do?
Melt.
It will melt.
So do you
Melt. Okay? So igneous rocks turn into lava and magma through the process of melting. This can happen if it's exposed to rocks way, way, way down, like so other magma comes up and touches the rock and it melts. Now, underneath the crust you have more plasticky, liquidy rocks. Okay, we'll learn about that later. For now, the deeper you go, the hotter it gets, the more it can melt.
You said igneous rocks turn into lava and magma?
Igneous rocks can turn into lava and magma through the process of melting.
Okay.
So you
Got
can
it.
melt an igneous rock
Yes, if I get a blowtorch, I can melt an igneous rock.
and it would turn to lava on the floor.
It would turn to lava on the floor.
That is so cool. Can we
There's
do that?
look up a video later, write down in your notes, backyard magma.
That sounds like a blessing.
Backyard magma is a professor friend of mine, and he does this. He takes a chunk of basalt and a chunk of igneous, puts an acetylene torch on it, melts it, and it literally drips off the corner of the rock and makes a lava. Okay? Now, in order to go back the other way, so how do we get from lava magma to igneous?
Cooling.
Cool it.
Cooling.
Water.
Well, yeah, it's got to solidify, right? It's got to solidify. Well, okay, so I'm going to write two words. It's got to cool. Now, what is in these rocks? What are rocks made of?
Minerals.
Minerals. And what do minerals do as they go from liquid to solid?
Make new minerals. No. They.
Remember how I said in order to make bigger crystals, the magma's got to cool slower?
Yeah.
Okay, they're making crystals, so this is a process called
Crystallization.
crystallization. Good.
Double.
Okay. This is the rock cycle for igneous rocks. You guys are so intelligent. You already know it.
Thanks, sir.
Did you get this? You've got to know this piece of the puzzle. Now that we know this piece of the puzzle, we're going to delve into what kinds of rocks can be formed when it cools and crystallizes lavas and magmas. Okay, but the process of making an igneous rock, well, it's got to be melted. It's got to be either lava or magma. That has to cool and crystallize at different rates. Like if it's on the surface, it cools fast. If it's underneath, it cools really slow. Now what are we? Slow cooling gives us what size of crystals?
Bigger.
Bigger.
Bigger. Fast cooling?
Smaller.
You guys are already there. Okay, because I said that's going to matter for rocks. This is where it matters. Do you guys have this written down?
Yeah.
Yes.
Okay, because I want to move on to the next slide. Almost got it. Okay. The formation of igneous rocks. This is everything we just said. So if you're having a hard time summarizing, this should have been your summary. From everything that we just talked about, I said that rocks crystallize from magma and lava, which is liquid rock. I said that they're like minerals, so the faster they crystallize, the smaller the crystals, or the slower they crystallize, the bigger the crystals. So this is everything that we just talked about. Does that make sense? So as we're learning how to summarize, this is kind of what you should be doing. Okay? You can write this down. I recommend you write this down like if you've been making a page for your rock cycle, like Jerry has here. This is really good. He's made, just kind of started out his rock cycle. Turn to a new sheet of paper and hold on to this one. So when we come back to this next class, we'll build onto this same chart, then we'll draw on the sedimentary rock. Then we come back the next day, then we'll draw in how the metamorphic rock affects it. That way we can build it one little piece at a time and it won't be so confusing. This introduces two concepts to you, actually three concepts, and we're going to talk about these concepts individually after this. First concept. Rocks that form near the surface of the earth are called extrusive rocks. Okay, so we have extrusive rocks, and we have intrusive rocks. Extrusive rocks have exited. Goodbye. They left the earth. They're no longer underneath the earth. They opened the door of the volcano and exited. Okay? Extrusive rocks have exited. Extrusive, exit. They're outside the earth. It's kind of a nice way to remember this. Intrusive rocks are inside the earth. They have not exited. They're inside. Intrusive. Inside.
So that means intrusive rocks are bigger?
Not that the rocks are bigger, but the minerals will be bigger. Okay? So, kind of tying off what Mr. Lopez just said, where the rock forms, extrusively or intrusively, where it forms determines the texture. Texture is how big the minerals are. Okay? If it's deep inside the earth, is it going to take a long time or a slow time to cool?
Small.
A long time.
Yeah.
Because it's like you're in bed, you got all the blankets up, and it's like a cold day like this morning, and you take the blankets off, and you get cold really fast, right? Like, I don't want to get out of bed, forget school. I keep my covers up. It's warm under my covers. Well, being inside the earth is like having the covers of all the rock above you, and the rock stays warm a much longer time. Extrusive is like taking off the covers and getting out of bed. You get cold really fast because there's nothing holding that heat in. So extrusive, you get fine-grained texture. Intrusive, you get coarse-grained texture. We're going to talk about this in a second. Okay. Okay, the first thing we're going to talk about is intrusive. Okay, so we're talking about the texture. Now these intrusive rocks, well, intrusive rocks take time to grow. They take a lot longer to grow. You can start to see the individual minerals. If you can see the individual minerals, it is intrusive, coarse grain.
What's coarse grain?
You can see the minerals. That's what coarse grain means. If you can see them, it's coarse grain. Because that means it had time to grow. So in the bucket you have in the front of you, you should have a granite and a gabbro. Go ahead and pull out your granite and gabbro when you're done taking notes. And I want you to take a look at these and see the size of the crystals. If you can see the size of the crystals, it's intrusive. So where it formed, intrusive, tells me it's coarse grain. Okay? So go ahead, pull them out of your... there's one more set that I'm just going to pass these around. Alright. This here, this is obsidian. Obsidian, this is, okay, you have coarse grain, you have fine grain, and then you have glass. There's actually one more texture, we'll talk about that in a second, but coarse grain, fine grain, and glass. Obsidian is volcanic glass. Pumice, not hummus, pumice is also volcanic glass, except...
Yeah, you just said hummus.
I said hummus.
I'm sorry. Sammy, stop talking please. Okay. Glass, obsidian, glass, pumice. Okay. Glass, obsidian, glass, pumice. They're both made of glass. The difference is one is solid as a rock, the other one is frothy.
What's frothy?
Okay, this is my best explanation.
Soft.
Alright, I'm going to pass these around. So let these go from table to table so you guys can take a look at them.
The light will, this feels like, what's that cereal called? It feels like, it feels like the mini.
No.
Feels like the mini.
really good. Is that really?
They're like cereal.
That is not full of rock.
Doesn't it? Okay,
That's really
They were like the mini
good.
cereal though.
hummus, listen, hummus, if you put it in water, will float. It is the rock that floats.
Hello.
Wait, hummus?
Hummus is the rock that floats.
That's a hummus.
Now, they're both made of glass. If you take, does anyone here have a soda?
Soda like a soda can that's filled up?
Yeah.
I do.
Well,
Why did you not explain?
I mean, come on, like we'll like show the soda for a second.
Okay.
It's gonna be some sweet.
So
Okay. Now we're not actually gonna shake up her soda, but if you shook up a soda, especially if it's on a warm summer day, you shake a soda up or it gets shook up and you open it, what happens?
It's gonna explode.
It just gets everywhere.
What if you top this up?
Now,
Does that work?
this is a really good example if you pay attention. If you let all that frothiness go, just put your phone away, Brianna. If you let all that frothiness go, the top part of the soda is going to be a whole lot of gas escaping from the liquid, right? And you get wet and nasty everywhere.
And then your soda's flat.
Okay, but at the bottom of the soda, it's still liquid, right?
Yeah.
So the bottom of the soda would be like the obsidian. It's still solid. The top of the soda, all that froth, is like the pumice. It's the same substance, except this one cooled with no gas escaping from it, and the pumice cooled with gas escaping from it. Does that make sense?
So weird.
Okay, they
What's the
look
buffer
very
now?
different, but it's the same material.
I feel like I could break this rock.
Toss
Please don't try.
Toss it.
Is it soft?
It's not that it's soft, it's not very dense, it's full of air holes. Okay, it's porous, would be a better way of saying that.
Toss it.
Okay,
You have to write this down.
You were like,
okay,
Oh, did you see that?
this chart,
Did you see it?
this chart, okay, don't write this down. Please don't write this down.
It was not my teacher.
This is, I pulled this out of the book.
We have a seat.
Okay, igneous rocks. Igneous rocks can be granites, mediums, or basalts, or felsic intermediate mafic. They can be coarse grain, or fine grain, or glassy, or porphyritic. Okay, I'm not. Just know that the porphyritic means it's not intrusive or extrusive. It started to form intrusively, and you see the big crystals, and then somehow it was ejected from the volcano, and then the rest of it cooled really fast. It's kind of like, I don't know what I am, kind of a rock. I'm sorry, this is the best example of andesite I have. Okay, enough of that. Do you guys realize that there's minerals in igneous rocks?
Yeah.
Yes.
Okay, here we
At least we don't have to cover it
go.
now.
Okay, this is important. You have coarse grain and fine grain. Coarse grain is intrusive, fine grain is extrusive, glassy is extrusive.
Wait, so extrusive is fine in what?
Extrusive is fine or glassy. Now you also have the colors of the rock. The colors of the rock correspond to what? Sean? The colors of the rock correspond to what minerals are inside the rock. So, rocks that are rich in feldspar and quartz are considered felsic, or feldspar, felsic. Okay, it's got lots of feldspar. That's this, if you, I don't know if you can see this, there's pink chunks in the rock. That pink chunk is feldspar.
Oh, it is?
You guys remember that rock we did the test on to see how hard it was? With the glass and the nail and that pink rock, that pink mineral?
Wait, so what's felsic?
Felsic is the concept of light colored rock. So if you get nothing else off this slide, you should get that felsic rocks are light in color. A lot of white, a lot of pink, right? Very light in color.
So feldspar is the pink.
Yes.
And felsic is the white.
Felsic is just the concept of the color.
Just trying to do
The
something.
concept of it's light color.
What about the black and white? What is that?
This is typically it's biotite. Might be a little bit of horn felt, but it's typically biotite. Okay. That's felsic. I'm gonna skip that one and we'll go back to it. This is all of today's igneous rocks. Mafic rocks are dark in color. Felsic, light in color. Mafic, dark in color. Mafic rocks are made of magnesium and iron. Magnesium, mafic, you kind of see where we get this name from. They're rich in, they're heavy materials. Iron is a very heavy material. I've got a rock here.
You have iron, ore.
This is called scoria. I'm going to pass this around the room. Scoria looks a lot like pumice, except it's much heavier. It's made of mafic. It's made from mafic lavas, not from felsic lavas. Pumice will float. Scoria will sink because it's heavier. It's got different minerals in it. Okay, you can pass that around. Okay, rhyolite and granite, gabbro and basalt. Do you see how these are both dark colors, right? But this one was formed intrusively or extrusively?
Intrusively.
Intrusive or extrusive?
Intrusive.
Okay, if it formed intrusive, that means it's inside the earth, which means it had a long time to
Sorry,
cool,
outside.
which means the crystals will be really big. Is that what this is?
No.
So this is extrusive. This is intrusive. Right, Tatiana? Okay. Okay, felsic mafic. Now, in the middle between the light colors and the dark colors, it's all about the minerals that are inside. If those minerals are kind of 50-50, it's got about 50% light and about 50% dark, you get something that's called a medium rock. You have these rocks, these are in the middle. This is diorite. It looks like salt and pepper. A little bit of white, a little bit of black, a little bit of white, a little bit of black, a little bit of white, a little bit of black. See how this works? It's just kind of a mixture right in the middle. It's not really dark. It's not really light. It's diorite.
Is that this rock? Is that category under this rock?
I can't see which one.
It's like a zebra color. We call it zebra color.
Yes, this is the diorite. This is diorite.
It's pretty rock.
Why are rocks so important?
It's the foundation on which you stand. You want to build a house? You got to know what kind of rock it's built on.
That's ground. Ground is rock.
Ground is not. Ground is like dirt and grass.
Under the dirt and grass and stuff.
What do you think ground is made of?
No.
Rocks.
Okay. Intermediate rocks are that mix. Now, once again, let's see if you guys can get this. Which one of these, the andesite or the diorite, is extrusive?
Diorite.
There,
Sorry, no, other one. That one.
Andesite. No crystals, extrusive. Visible crystals, intrusive. Or in the case of the sample on your table, the sample on your table is porphyritic because it has crystals and no crystals. It's a weird mix. Okay? Okay. Look at the andesite, you'll see. They start to form underneath the ground, and then they're ejected, and then they cool really fast. So they have, so they have some crystals but no crystals.
Oh, so it's not like covered all the way.
Yeah. Okay. This will be on the test. Okay? I'm not asking you to copy this. I'm asking you to be able to read this. That's all you have to do. If you can read this, you'll be okay. But I'm not going to test you on stuff that you can't understand. So like the first chart, hold your question, I'll get to you. You have felsic rocks, intermediate rocks, and mafic rocks. And ultramafic rocks, but we're not going to talk about these very much. Okay? You can have coarse-grained felsic rocks like granite. You guys have granite at your table. Or a fine-grained felsic rock like rhyolite, or the diorite, the andesite, or the gabbro basalt. Do you see the samples on your table? Do they match this?
Yes.
They should.
Yes.
If you're awake, Collier. Head up, man.
Get my face sleep.
Come on, head up. Okay. I said that the reason that these are dark is because they have dark minerals. What this chart tells you is what are those minerals? Well, mafics are made of pyroxene, olivine, and amphibole with some plagioclase feldspar. That's pretty calcium rich.
Wait, how do you do that?
I'm looking. Mafic rocks are pyroxene, amphibole, and calcium-rich plagioclase feldspar. Okay? With a little bit of olivine.
So
This is what it's made of.
basalt, basalt, it's
Yeah.
the same thing?
Basalt is the same category, except this one is
That one's
fine grained, not coarse grained.
So it's made of the same stuff as
Made of the same stuff.
Okay, that's what I was wondering.
Okay, well good, good. Glad we got that. Okay, your medium rocks are a nice mix. Your felsic rocks, guys, that's your last warning to stop talking. Your felsic rocks are here, so they're made of lots of quartz and potassium feldspar. Okay, a little bit of biotite and a lot of muscovite. Okay? Now, the other thing that you need to know on this chart is these arrows down here. Okay. Dependent variables, okay, this should be the independent variables. This gets a little confusing, so I'm trying to introduce this to you. You have more silica-based rocks on this side than this side, because that's what the arrow says. Okay, there's more iron on this side, because that's what the arrow says. Alright, the big thing that I'm going to kind of try to get you to see is what temperature do I need to melt these rocks?
Like pretty hot. Pretty
Okay.
hot. Sir.
1,000.
These ultramafics are like 1,250 degrees Celsius. Really, really hot to melt these guys.
Same.
How much is that in Fahrenheit?
Really, really hot.
How about a
Okay,
million?
over here, the granite rocks, they only need to be 650 degrees Celsius to form. So the granites actually form closer to the surface. These ultramafics and mafics form deeper underground.
How do they find those?
How do we find them?
Do you like drill a giant hole looking for rocks?
Well, you get the fine-grained basalts happen like volcanoes like Hawaii. They're all over the place in Hawaii. And sometimes we are in a mine and we come across these rocks. Sometimes in a quarry you come across rocks. So sometimes we dig, sometimes they've been brought to the surface.
So the
Ultramafic do not survive on the surface very long. They tend to break down very quickly.
why?
They're more susceptible to weathering things like wind and rain and gravity dropping it. It breaks really easy. It falls apart quickly at the surface.
So can you preserve it though?
Yeah,
How?
take it away from all sources of weathering.
So put it in a like glass box?
Put it in a glass box with no sunshine, no wind, no rain, no water. It'll preserve it.
So in it like a darker room?
Mario.
Well, not always. But you can preserve things from weathering simply by bringing them inside the house.
Oh.
Okay. What? All right, we are almost done with this PowerPoint.
Oh, I learned that in 4th grade.
I live there.
Okay.
Sir.
You've got to know the geologic provinces of Virginia. So as you look up here, go ahead.
We're mostly orange, sir.
We live right here.
We're orange.
Somewhere about right here.
I thought we lived in Perry.
Well, I mean, it's kind of right here. We live right here.
How long would it take us to get to the border of South Virginia?
To the south of Virginia?
Yeah, the border of South Virginia.
It's like 4 hours.
From us right now.
What do you mean the border of South
Like
Virginia?
up to the very bottom.
Do you mean the southern border of Virginia?
Yeah.
That will take you about 3.5 hours,
John, do not take your
depending on traffic.
It's a mission, sir.
Okay.
I'm going to stay. Wait, what? I'm going to
We live on the edge of the Piedmont and the coastal plain. And we're going to talk more about this later, but what you need to know here is that Piedmont to coastal plain, we're in the Piedmont. If you want to go to the coastal plain, go down to the mouth of the Occoquan. You know where the Occoquan has all those big boulders and there's like the marina down there?
Yeah.
That's coastal plain. If you go up where all those boulders are to the reservoir, that's Piedmont. That's the border right there. Okay? There's the coastal plain, the Piedmont, the Blue Ridge, the Valley Ridge, and the Appalachian Plateau. Draw this in your notes right now. Draw this in your notes.
I can't draw Virginia.
How do you draw Virginia? It's almost like a triangle on its side.
But all these little zigzaggy.
I know.
You poor thing. You can do this.
I'm not an
Yeah, you
artist,
should
man.
draw this thing.
Wait till I start drawing this on the board. It's going to be hilarious.
I wanna see it right now.
Draw that. Yeah, I'll draw.
Well, right now I can trace it. It's not going to look quite as hilarious.
Huh?
Oh, he's gonna trace it.
Like right here.
Yeah, that's cute.
He's gonna take the easy way out.
Heck yeah.
No.
Dang.
When it comes to drawing,
The easy way is the best way.
It's taking me like 5 minutes.
Yeah, I'm still on like the
Nothing
bottom.
like Virginia. Okay, what's that little island?
Dang, this does not look like Virginia at all.
I'm here.
Oh my god.
Mine is not.
this is the eastern shore.
Mine looks like a dragon.
This is not actually an island, it's a peninsula. So above this is Maryland and Delaware. This is called Delmarva. Delaware, Maryland, Virginia.
Dang.
You said Delmarva.
Why?
Why can't you just say DMV?
Delaware, Maryland, Virginia. It's the abbreviation of all of those. Is that Delaware's on that peninsula, Virginia's on that peninsula, and Maryland's on the peninsula. So Delmarva, the Delmarva Peninsula.
I'm hearing what
We
you're
call that the eastern shore. It's part of the coastal plain. It's like the coastal plain doesn't disappear right here. It's just this is Maryland.
saying. On-time train.
Okay? This is Maryland right here. We're just seeing the part of this that's Virginia. Okay? Then there's the Piedmont. Do you guys ever look in the distance and like, oh, I can see the mountains today?
Yeah.
What you're seeing is the Blue Ridge. The beginning of the Blue Ridge. The very western edge of Prince William County actually touches the Blue Ridge. So you're seeing to the other side of the county. And then, like, on the edge of the Blue Ridge on this side, you have Shenandoah National Park. And then you have the Valley and Ridge. Has anyone heard of Luray Caverns?
Yeah, I've been there before. It's
Okay,
boring.
good. Luray Caverns is in the Valley and Ridge. So, Blacksburg, James Madison, Eastern Mennonite, all these schools are in the Valley and Ridge.
Wait, like JMU?
And then they have
JMU is Valley and Ridge. Okay?
How are the houses down there? Pretty big.
expensive.
I don't know. I didn't go to school there. Can't tell you.
Seem pretty big.
Okay, and then way down here in the corner is we have a little toe into the Appalachian Plateau.
That's like Compton.
Okay? Alright, so here's my question. Which province do we find igneous rocks? I wonder which one this is. The Blue Ridge. Okay? We find igneous rocks in the Blue Ridge. It's possible to find some in the Piedmont, but it's much harder because they've all been metamorphosed. Okay, so where do we find igneous rocks? In the Blue Ridge. So if I asked you a question on the test, shade in the province that has the igneous rocks, could you do that?
Yeah.
Still, give me those eyes, man. I want to see those eyes.
I could.
Pretty young.
Marker. Nice.
You're so pressed.
You don't know nothing.
Previous Steven.
Yes.
You're pressed. You're pressed. On the situation. You're pressed on the situation.
Okay.
You want it to happen.
I'm going to tell you a little bit about the Blue Ridge Mountains and the Blue Ridge Province, and then we're going to be done. Okay? This is going to be quick, but this is on the SOL, so don't be like Mr. Cord just trying to give us something nice. This is on the SOL. The Blue Ridge Mountains are part of the Appalachians. They're the highest mountains in Virginia, and they're the oldest rocks in Virginia. Very important, you know that.
Blue Ridge, oldest rocks in Virginia.
Oldest rocks in Virginia.
Got it.
Appalachian Mountains.
Blue Ridge, Appalachian Mountains. Got it.
I remember this. Not.
Okay?
Got it.
So Blue Ridge, part of the Appalachians. It's the easternmost edge of the Appalachians in Virginia. This is also where you get the highest mountains in Virginia. The second highest peak in Shenandoah National Park is actually accessible from a trail. You can, it's about 1.5 mile, 2 mile hike. You go up to Stony Man Summit.
Is that where?
Oldest rocks in Virginia. Okay.
What?
Come on, thanks.
The fact that they're the oldest rocks in Virginia is important.
Squat,
Okay. What type of rocks do we find in the Blue Ridge? Igneous and metamorphic rocks. Okay, igneous metamorphic rocks. They're very old. They're like upwards of 1 billion years old. They're very old. Okay, what you really need to know is you really don't find very many fossils in the Blue Ridge. You can find some, but you don't really find a lot. Okay, why? Because the Blue Ridge is made of igneous rock. Okay, a fossil is the remains of something that died, that got buried in sediments. How does igneous rock form? It goes from, starts with what? Was that Danny? Lava. Can creatures' bodies survive in lava? No. Remember Gollum on the edge of Mount Doom falls into the lava and melts? Okay? We don't preserve fossils in granite. Okay? Okay, let's see if you guys can get this. What is A?
Igneous.
What is B? Lava, magma. What's C?
Cooling crystallization.
Cool and crystallizing. What's D?
Melting.
Melting. Melting. Oh, what a horrible world. Yeah. Tomorrow, I'm sorry, not tomorrow, but next class, we're going to add on to this sedimentary rocks. But for right now, all you have to worry about is just this. Make sure you know this.